Statistics and Excel introduction. Got data? Let's get into it with statistics and Excel. Course structure and intentions. This course deals with the analysis of data and statistics, emphasizing its essential role in our everyday decisions and understanding of the world. We generally have a sense that statistics, it's important, it's involved in many different things, but usually we don't have a sense of just how important statistics is and just how involved it is in many areas of our lives, including our personal decision making, our place of employment, our entertainment, our news. Let's take the news, for example. Just about every claim that is made by the news, we expect to be supported by some form of statistics. Now, unfortunately, the news alludes to this usually by saying the experts say this. So they refer to the experts. But when we hear the experts, we don't assume that they said something, these experts, and the world changed to conform with what the experts say. We assume that the experts took some kind of data, made some analysis about it that gives some insight about the world. When we think about entertainment, for example, when we watch sports, watching the sports is entertaining, but usually we want more information about the sports. We want to know the stats of the team. We want to know the stats of the players. We're comparing different teams to other teams and players to different players. We're comparing team stats in the current year to prior years and so on. But in the prior year, they had different rules. So how can you compare the current player to the prior year player and so on? And we get deep into these statistical analysis. And like when you're thinking about sports, really sports is just a form of a job. So all of that kind of analysis that people apply to sports really applies to our place of employment oftentimes as well. If we go into our boss's office and we're like, we would like a raise, it's not enough to say, well, look, I could really use some more money right now. We have to say something like, look, this is what we're doing. This is why we deserve a raise based on this kind of statistical type of analysis. And clearly with our personal decision making, when we make purchases at the store or purchase like a car, we're usually going to do some kind of statistical analysis to help out with that decision-making process. We don't have to. We could just be like, hey, look, the label, I like the label on this one, and the other one, the label's not as, you could do something like that. But usually we're probably better off if we do some kind of analysis, right? So we will examine data's role in various fields such as medicine, finance, weather, prediction, education, and social trends. So as we do our example problems, we'll try to pull data sets from many different areas so we get an idea, a sense of where statistics is involved in many different areas. We can't, of course, do examples on all the areas that statistics is involved in because, again, statistics is involved in many, many, many areas of our lives. That's also reflected, by the way, if you look at college degrees. Any field that you go into is usually going to have some kind of statistical requirement in it. So you can't really get away from the statistical requirement, not because they want to hurt you with statistics and you don't want to take it or something like that, but because statistics is going to be important no matter what field you are in. Clearly science, it's going to be important. Clearly, any kind of economics or finance, it's going to be important. But even if you're in like English, it still can be quite important, because you're going to be analyzing different texts, and you might analyze things like, well, how often do they use this rhetorical trope? How often does Shakespeare use this kind of rhetorical trope? Or how often do they use a certain phrasing of words? You might actually be using English to try to determine who the author was of a certain thing. And one way you might do that is to look at the words and how often the words are used to try to determine if it's the same person that wrote one thing versus another thing. So even in like English and philosophy and that kind of stuff, statistics is going to be important. However, it's crucial to remember that the data themselves do not inherently hold meaning, but require appropriate interpretation through statistical tools. So we often hear the term, the data is telling us this. Now, note that it's not too bad to hear that term but what we're really saying, if someone says the data is telling us this, they're saying, hey, look, I took this data, which is just random. It's not telling us, the data is just data. We can't get anything from just random data. We took the data and we compiled it in such a way that we think we can infer something from the data that is true about the world. So the compiling of the data is going to be important. Just data itself doesn't just tell us something. And notice that that's really important to note, because today we have data, we have too much data. Data is everywhere. So we have to put the data into a format that it tells us something. Otherwise, the data is really useless to us. So the two sides of data, use and misuse of statistics. So we will explore how data can be used to clarify and mislead, echoing Mark Twain's attributed quote, "There are three kinds of lies: lies, dang lies, and statistics." I cleaned that up a little bit, but we've probably heard that phrase. There's lies, dang lies, and statistics. So the idea being there is that the statistics are meaningless. It's useless. We're not getting anything from the statistics because people just lie with statistics. However, note that there's truth to that. You can lie with statistics. But the same thing can be said of just words, right? People can lie with words. Words are just a tool to help us to put meaning to the world, to try to convey meaning from the world to other people. So we can use the same thing with words. We can take something that is true with words and then go down a bad path from there. So what does a liar usually do? A liar is going to take something true and they'll say, this is true, this is a fact. And you're going to say, yeah, that is a fact, right? And then they distort it from that point, and we end up going down a road because there's been entered into the lie has been entered in some place that we didn't catch, right? Because it started out with truth, then the lie happened, and now we went down a road and we don't even know who we are or what we are anymore because somehow we got that distortion involved. And if you think about this from a philosophical perspective, some people think that evil, in essence, is a distortion of the truth, right? Because everything is good. So where does evil come from? Some kind of distortion of what is good. A lie, a deception has been entered into it, and we've taken a wrong path. So what are we trying to do with our tools, whether it be language or whether it be statistics? We're trying to find truth. We're trying to be alignment with what actually is, and that's the general strategy. Note also that there's some philosophies that basically have the idea that there is no truth, right? That everything is relatives, and the tools that we use, which are even language itself, is just a relative tool. There's no actual meaning to it. And if you adopt that kind of mentality or that philosophy, it becomes difficult to apply reason itself. And it's going to be difficult to do statistics, right? Because the idea of logic is that there is truth. You almost have to accept that a priori. That's got to be your first assumption. There's truth about the world, and we're using our tools, that being language, that being statistical tools, in order to infer what that truth is, so that it will be revealed to us through some these are some tools that we can use to reveal the truth. So obviously the same things can be done with statistics. We can use one piece of statistics, one little thing. We say, hey, that's true. Look at this is true. You can't deny that. And then they go from there and they introduce the lie from that point. And then we go down a road that's not correct, just like we do with words. But that's not the statistics' fault, just like it's not the words' fault. You misused the statistics. So what we want to do is say, just like we're pretty good at seeing what a liar is with words, we want to apply those same skills and see how people lie with statistics, which is almost as important, if not as important, as seeing how people can tell the truth with statistics, so that we can tell the truth from the world with the tools, and we can see how people will mislead with these same tools, not blaming the tool, but blaming the liar that's using the tool to mislead, or possibly making a mistake if we're having a good. So some people will say, however, it's also easier to lie without statistics. In other words, if we didn't have the tools of statistics that would allow us to catch the problem, then everything would be relative. Like if there was no truth or was no statistics, it's actually easier to lie, because there's no way to really test what is actually, true. So purpose of statistical tools. This course aims to arm you with the principles and ideas of statistics necessary to draw meaningful conclusions from data. We will cover probability and how it aids us in understanding and quantifying the unknown. So what we would like to do is be able to apply these tools to try to be able to see when people are lying and see how we can extract truth from a set of data. Not everything can be quantified. Notice that's another thing that people often have an issue with. They take issue with and say, well, not everything can be quantifiable. But a lot of things can be, right? And the more that we can actually apply a rigorous test, in those areas, we want to be able to do that. If we can fairly measure something, we want to be able to fairly measure something, recognizing that not everything can be measured, exactly that way. But primary challenges in statistics. So you can kind of combine statistics or group statistics into two main buckets. So the one bucket, comprehensive data analysis, and the second being the statistical inference. Now, in my experience, most people, when you say statistics, kind of think about this second concept, because oftentimes they're thinking about polls, for example, election polling, or trying to find out something about a population from a sample, which is a common practice within statistics. Scientific practices often are doing a similar type of thing. We're taking some kind of sample and trying to understand the full population. The other would be a comprehensive data analysis. So in this case, this challenge involves extracting meaning from a complete data set. For example, using comprehensive records of a university's students, we might predict future performance based on incoming SAT scores and high school rank. So in other words, we might have the full data. We know all the data about the SAT scores and their high school performance. We have all the data. We're not trying to infer what everybody's SAT scores were. We have all the data. What we're trying to do is organize that data set to possibly give us some understanding about something possibly in the future, right? Such as college performance that's going to be happening in the future. Whereas the statistical inference, this challenge relates to making inferences about a larger population based on a sample. So examples include predicting election outcomes based on a poll, or predicting the average height of a population based on a sample data. So this is the one that, like, if you're trying to predict who's going to win the poll, then you can try to see what people are going to vote for, right, early. And so what you're doing is you're taking a sample and trying to infer what's going to happen in the full population. A lot of scientific analysis, if you're trying to determine something, about a population or species or something like that, or if you like the height of something or whatever, you can measure. You're going to take a sample. You're going to take a sample of the population, and then see if you can make some kind of statistical analysis about the full population. And so we'll take a look at those in the future. So course goal. This course will provide you with numerous intriguing examples demonstrating the practicality and wide-ranging applicability of statistical analysis. We will look beyond the notion of merely plugging data into formulas to comprehend the logical foundation and strategies underpinning statistical reasoning. In other words, oftentimes when people are learning statistics, they might be taking a statistics course in college just because they're required to take it, and they're just learning formulas and how to plug numbers into formulas to get the proper result, the answer, so they can pass the college course. The problem with this approach is that you're not really getting a deep understanding as to the why you're plugging the numbers into the formula and what are the underpinning principles for plugging those numbers into the formulas. Now, oftentimes, to get a more full picture of the rationale for the statistics we're doing, we can use pictures, we can use charts and graphs, and Excel is a great tool to help us to do that. Now, it used to be that when we learned statistics, we would have charts and graphs that would be in a demonstration in like a lecture format. But then when we actually do the statistics, we're just plugging numbers into formulas. But these days, of course, we have the application of Excel, which allows us to create our own pictorial formats of the charts and graphs much more easily. And we'll try to do that as we go through our practice problem. So the other problem oftentimes is people that learn how to do formulas in Excel without understanding the math or the rationale underpinning the formulas in Excel. So Excel will actually shorten up the math so it's even easier to plug the numbers into Excel to get a result. However, again, the problem is that if we don't understand the rationale for the data we're putting into the system, the result's not going to give us as much information that we can make decisions on as it otherwise would. So our ultimate goal is to import a genuine understanding of one of the most useful, influential, and universal modes of reasoning in today's world. So again, just noting the common use of statistics. It's basically everywhere. It's not too difficult once we understand the rationale of the statistics. And if we understand the statistics that are being used everywhere, we have a tool that really a lot of people don't have that can be used, quite often. So this understanding is becoming increasingly vital as technology continues to facilitate access to more significant data sets and advanced analysis techniques. So clearly with the internet, we are flooded with data these days. So getting the data is not the problem. It used to be, it's still a problem in some areas, but there's a lot more data. It used to be that getting the data was a lot more difficult. Now we have a whole bunch of data all over the place, and the problem often is to try to put that data in a format that we can make decisions on. Now, if we can't understand how to do that, we're going to be reliant on, quote, the experts, end quote, in order to compile the data and tell us what the data means. And I'm personally less, or I guess I'm more skeptical about relying on the experts. I would rather have some idea of what the experts are doing to, interpret the data. So, and those skills I think will be useful in everyday life. So tools. Obviously, we're going to be using math tools for statistics. The math is important because that'll help us to get the underpinning principles and concepts, but we'll also be using Excel. Now, Excel will allow us to use functions, which shorten up the math. So sometimes it's useful to look at the equation, the math equation, because we can intuit meaning from the equation, but it's also useful in Excel to get the answer more quickly. But Excel can also be used to make those pictorial representations. Now, I just want to point out, oftentimes when we think about pictorial representations of data, many people kind of have a disparaging idea in their mind of that, as though there's someone like Einstein with his crazy frizzy hair and whatnot, the mad scientist, is able to actually do all the calculations and is learning everything just strictly from looking at a formula. This isn't true, I don't think, but this is the idea that we have. And then, in order to dumb that down, to give a, like we're children, like a picture book, they have to make an image of that to explain the genius, Einstein, to us mortal people, right? So then they make an image of the data so they can tell it to us. But that's not really how it works in practice, right? Even if you are the Einstein, you are often working in images as well as formulas. It's often the other way around. I mean, Einstein was actually quite good at visualizing things. So he's famous for basically visualizing what it would be like if he was falling at the same speed as a beam of light, right? What would that look like? So he actually kind of envisioned that, which helped him to formulate his mathematical formula. So it's kind of difficult to say, which came first, his visualization or he had this idea in his head. So the pictures are quite important, even if you're like an Einstein, right? That the point is that we want to have a pictorial representation, because the pictorial representation will tell us things about the data that a formula representation may not, and just organizing the data certainly will not tell us, or just a random set of data certainly will not tell us. Excel, great tool for being able to do that, and many people of course have access to Excel now, so the ability to put some data in Excel and do some basic analysis of it can help you in any area, like I say, like your personal decision making, in your work decision making. You're comparing yourself to other performance at your job, what kind of purchases you should make, even your entertainment, when you're looking at who's the better sports player and this kind of stuff. Being able to put the data in Excel, useful. So two key terms in statistics: data and statistics pose a common grammatical question: are they singular or plural? Now, notice that when we think about statistics, I do want to point out that terminology is important because we want to come up with actual definitions, because the definitions will help us to communicate with others about statistics. But this particular kind of issue, I don't think is as a problem for normal communication, because if you're an English speaker, the normal kind of use of statistics, I think people will understand what you're saying for the most part, although some people might get a little, have their preferences on exactly how you should be using the term data when it comes to plural versus singular. So just to point it out, data, this word originates from the Latin datum, which signifies a single piece of information. Therefore, data is the plural form and is typically used to refer to multiple pieces of information. So when you think about data based on where it came from, you'd say, well, the data is the plural, and then datum would be a singular piece of data. But oftentimes when people say data, then they might be saying it's a piece of data, right? If you're saying it's one data, people might say it's one datum, it's one piece of data. As long as you have to be somewhat specific to know exactly what you're saying. But we have the plural and the singular is a little bit different in English than other plurals and singulars is kind of the issue, right? Because you would think it would be like datas with an S for the plural versus the singular. Anyways, however, in contemporary use, data is often treated as singular when referring to a collection or body of information. So clearly when you're talking about the whole set of data, like if you're talking about a bunch of data, a bunch of pieces of data, the plural would be the data. There's the multiple data. If you're talking about the whole set itself, now you're talking about one singular thing, and people will still usually refer to that as the data. Now, to be more specific, you might call one piece of data, like that's one singular piece of data, right? A piece of data or a datum. And then if you're talking about all of the data, that is all of the data, right? And if you're talking about the data set, you might say like, well, that's the data set, or something like that to kind of try to be more specific. But again, statistics is similar kind of issue because it's got this S on the end, which usually indicates a plural in English, a lot of English words. But statistics, the term statistics can be both singular and plural depending on its context. So for instance, statistics is singular when it refers to the field of study. So when you're talking about the field of statistics, you don't say singular, it's the field of statistic and drop the S. That sounds funny. If you're an English native speaker, it would sound funny to you. You wouldn't do that anyways. But if you think about it, these words are a little bit weird with regards to English singular versus plural because of, they're not structured with like an S for the plural. So on the other hand, statistics is plural when it refers to numerical facts or pieces of information derived from the data set. So when you're talking about these are the statistics, the mean, the median, and whatnot. Those, now you're talking about multiple things, and you're still going to say statistics, right, for multiple. So for example, the statistics from research show a significant trend. Okay. Common misconceptions about statistics is that it's about distilling complex situations down to a word or two. This oversimplifies the reality of statistical analysis. So simplistic perception. So many people perceive statistics as a means of condensed complicated scenarios into a few words or numbers. This viewpoint, while it captures one aspect of statistics, doesn't fully appreciate the intricacy and potential statistical analysis. So in other words, we're usually, as human beings, we want to kind of get a quick answer to something. So when we look at a set of data, we basically want to say, okay, what does that data tell us? And let's go on to the next thing. We do this. We do the same thing with everything, right? Because otherwise we would get bogged down with too much information. So we use shortcuts, heuristics, and things like that. So like when we talk about people, we can say, well, that person's like this. He's like this kind of person or something like that. As if, obviously, when we say that about someone, it doesn't mean that's way too simplified. Or if we say a book, the book is saying this, or a philosopher is saying that. That's what that philosopher says. And we try to put everything into a very specific box, and then we can move on to the next thing so we can learn something else. But clearly, if we're talking about a book or a philosopher or a person, that's way too simplified if you want to get into a more nuanced understanding. And normally the same is going to be with data. It's like a book, right? It's a bunch of information. So if you take a whole set of data that has been compiled, there are oftentimes going to be multiple stories that you might be able to compile from that data. Now, when you look at data from a scientific perspective, the point is that you're trying to trim down all the other noise so that you can test one thing at a time, a hypothesis, and then a testing of the hypothesis. But when you're looking at just a set of data and you're trying to say what is coming from that data, there could be, multiple different stories, coming from the data, right? So the reality of statistical analysis, rather than being a simple summarization tool, statistics provides a set of methods to analyze and interpret complex collections of information. The challenge lies in extracting meaningful insights without losing significant detail from the data. So the other way people often simplify the data is they'll try to break it down to one number, usually the average or the mean, sometimes the median, and then they'll say, well, that gives us the full picture of the data. But clearly it doesn't, right? Because if we don't know the spread of the data around the mean or the median, then we don't have as much information as we would if we knew the actual, and a picture of it actually helps with that a lot. So the need for tools and vocabulary. So to accurately convey the complex information inherent in data, it's crucial to develop and utilize appropriate statistical tools and vocabulary. These tools help us interpret and describe data in ways that maintain a balance between simplicity and detail. So clearly, when we're trying to communicate more detailed information, then coming up with tools that can give a more specific description about characteristics of data, like the spread and stuff like that, is quite useful. The pictures are still useful as well, because that gives us a different visualization, but the definitions are important too. So don't let the deconstructionists tear down our definitions of statistical analysis, because we need to agree on terms in order to actually communicate coherently about the truths that are in the world that we can discern with our analytical tools and our senses. So the ultimate goal of statistical analysis is not just to simplify, but to create summary descriptions that are both straightforward and meaningful, capturing the richness and diversity of the data without losing vital information. So it's a balancing act. That balancing act can be quite complex and is somewhat of an art form, because we want to simplify the data so that we can find meaning from it, but not oversimplify it to the point that we have actually taken meaning away, or worse, we come to conclusions that are incorrect.